In a survival scenario, caloric conservation is the highest priority. Inefficiency kills just as surely as hypothermia or dehydration. Every movement must have a purpose. Every calorie expended must yield a return. The knife is the supreme efficiency tool. It allows you to process fuel, construct shelter, and procure food with minimal energy expenditure. Without a knife, you are reduced to tearing and breaking materials with your hands, a recipe for injury and infection. With the knife, you can manufacture every other tool you need. However, owning a blade does not grant you the ability to use it. Most people view a knife as a weapon or simple cutter. In a survival context, it is neither. It is a wedge, it is a plane, it is a striker, it is an extension of your skeletal structure. This briefing covers the selection of the tool, the biomechanics of its use, and the specific techniques required to sustain life when infrastructure fails. Section 1. Selection criteria. Discard the notion of the massive Rambo-style survival knife. Large, heavy blades are unwieldy for fine tasks and add unnecessary weight to your kit. Conversely, folding knives introduce a mechanical failure point. The pivot joint will fail under the stress of heavy wood processing. For a primary survival tool, you require a fixed blade. The blade length should be between 4 and 5 inches. This provides enough length to span the width of a standard log for splitting, but remains short enough for precise carving. The construction must be full tang. This means the metal of the blade extends through the entire length of the handle. Partial tangs will snap when you apply leverage. If the handle breaks, you are left with a piece of sharp scrap metal. The spine of the knife should have a sharp 90-degree edge. This is not a manufacturing defect, it is a feature. It allows you to scrape bark for tinder and strike a ferrocerium rod without dulling your cutting edge. Steel choice comes down to carbon versus stainless. Carbon steel is easier to sharpen in the field using natural stones, but is prone to rust. Stainless is corrosion resistant, but harder to hone once dulled. For most terrestrial environments, high carbon steel is superior, provided you maintain it with oil or animal fat. A rusty edge is a dull edge. Section 2. Biomechanics and safety. Before the blade touches wood, you must establish the blood circle. Extend your arm with the knife and rotate 360 degrees. If any person or object is within this radius, do not unsheath the knife. Grip determines control. The standard hammer grip, wrapping all fingers around the handle, is for power cuts, but lacks precision. For controlled removal of material, you must utilize the chest lever grip. To execute the chest lever, hold the knife in a reverse grip, edge facing away. Place the knife against the wood. Lock your arms to your torso. Use your back muscles and rotation of your upper body to pull the wood through the blade or the blade through the wood. This utilizes your strongest muscle groups and keeps the blade close to your center of mass, reducing the risk of slippage. Another critical grip is the knee brace. When seated, brace your forearms against your knees. This eliminates the variable of arm swing. You are creating a closed kinetic chain. The knife moves only by the articulation of your wrists or the swaying of your torso. This is essential when fatigue sets in and fine motor skills degrade. Section 3. Processing fuel, batoning. Fire is life. To sustain a fire, you need access to the dry inner heartwood of logs, especially in wet conditions. You cannot achieve this by hacking. You achieve this by batoning. Batoning transforms your knife into a splitting wedge. Place the blade horizontally on top of a log, perpendicular to the grain. Do not strike the knife handle. Using a separate heavy stick, the baton, strike the spine of the blade directly above the wood. Once the blade is buried, continue striking the spine that protrudes from the other side of the log. Drive the blade straight down. This splits the wood with mechanical precision. Caution: ensure your baton fits the spine of the blade, not the handle scales. Do not baton through knots. They will chip or roll your edge. If the knife gets stuck, do not pry sideways. Prying snaps tips. Instead, use a wedge made from another piece of wood to free the blade. Section 4. Tinder preparation. Feather sticks. Once the wood is split, you need tinder. A feather stick is a piece of wood with thin curls shaved from it, remaining attached at the base. These curls increase the surface area of the wood, allowing it to catch a spark instantly. Select a straight-grained piece of wood. Place one end on a solid surface or the ground. Do not carve into the air. Place the blade near the top of the stick. Apply consistent downward pressure. The goal is not to slice the curl off, but to stop just before the end. This requires a sharp edge and a locked wrist. If you're shaving thick chunks, your angle is too steep. Flatten the blade against the wood. You need curls thin enough to pass light. A proper feather stick should look like a fuzz ball. This cluster of dry wood fibers will accept a spark from a ferrocerium rod when natural tinder is wet or unavailable. Section 5. Structural cuts. Notching. Rope and cordage are finite resources. You should not waste 550 cord on simple lashings that can be replaced by joinery. The knife allows you to create mechanical locks between pieces of wood. The most versatile cut is the 7-notch, or a square notch. This allows 2 perpendicular logs to sit flush and lock together, essential for building shelters, traps, or drying racks. To cut a notch, stop cut first. Place the knife vertically across the grain where the notch ends. Baton or press the blade into the desired depth. Then slice from an angle towards the stop cut to remove the chip. Repeat until the notch is square. For tent stakes or trap triggers, you need the toggle cut. This is a reduction of the wood's diameter to create a catch point. Use the thumb push technique. Place the blade on the wood and use the thumb of your non-holding hand to push the spine of the blade. This provides extreme control and prevents the knife from slipping and severing a tendon. Section 6. Processing game. If you acquire game, the knife is your surgical instrument. The rule here is do not puncture the gut sac. A punctured stomach ruins the meat with bile and bacteria. Do not stab. Lift the skin, make a small incision near the rear of the animal, insert the tip of the knife, edge facing up, under the skin. Run the blade up the center line, cutting the skin from the inside out. This parts the fur without cutting hair, which keeps the meat clean and lifts the skin away from the internal organs. For disjointing, you are cutting connective tissue, not bone. Locate the joint by manipulating the limb. Insert the tip into the cartilage gap and sever the ligaments. If you are hacking at bone, you are dulling your knife and wasting energy. Anatomy is a map. The knife simply follows the roads. Section 7. Field maintenance. A dull knife is a dangerous knife. It requires more force to cut, increasing the likelihood of slippage. In the field, you likely won't have wet stones. You must improvise. River stones can serve as grinding surfaces. Look for a flat, smooth stone with a fine grit. Lubricate with water or spit. Match the factory angle of the edge, usually 20 to 25 degrees. Push the blade across the stone as if trying to slice a thin layer off the top. After grinding, you must strope the edge to realign the microscopic burr. Your leather belt is the ideal strope. Anchor the belt to a tree and pull it tight. Drag the knife's spine first along the leather. Flip and repeat. This polishes the edge to a razor finish. Rust prevention is constant. Blood, plant sap, and water will corrode carbon steel overnight. Clean the blade immediately after use. If oil is unavailable, rub the blade against the side of your nose or forehead to pick up natural skin oils, or use animal fat. A rusty edge is a dull edge. Conclusion. The knife is not a magic wand. It is a piece of steel that amplifies your intent. Buying a $300 knife does not make you a survivor. Understanding the geometry of the edge, the physics of the lever, and the biology of the user does. Practice these cuts. Go outside and make a feather stick. Split a log. Cut a notch. Do it until your hands learn the geometry. When the grid goes down, you will not have YouTube tutorials to guide you. You will have your hands, your mind, and your edge. Make sure all 3 are sharp. End of briefing.